Hello again. We are back together now to continue our journey of solving one-step equations. So far, we have learned how to solve one-step addition equations, one-step subtraction equations, and now we're moving on to one-step multiplication equations. So just a quick review as we've gone over for the last couple of days, we need to use inverse operations to solve these equations. So inverse is the same as saying the opposite. So we need to use opposite operations to help us solve our one-step equations. So if we're looking at multiplication equations, the opposite of multiplication is division. So today we are going to be solving these one-step multiplication equations by using division. Now, there's many different symbols that mean division. So we have our classic symbol here. We have this is our classic symbol that means division, right? And then we also use, when we're using long division, right? We've talked a little bit about the top dog goes in the house. We draw the little house as one form of division. We also see, like on our computers, when we use those, we have this slash. And the final thing that we've talked about that means division is actually this fraction line, right? And it kind of references our classic division symbol because we have the fraction line here, and then we have some value that goes here and another value that goes on the bottom. Now, this way of writing division is going to be our new best friend. This is the way we must write our division equations. So if on your homework or on a test I see you using the division symbol, I am likely not to give you full credit. We're going to really start looking at fractions and division as the same thing. So we're going to go ahead here and look at the bottom of our page and go straight to some examples. So if I'm looking at example letter A, I have 3x equals 15. Now, I'm going to solve these the same way that I've been solving my addition and subtraction equations. The very first thing I need to do is I need to go ahead and draw in those railroad tracks. And I know at this point I sound like a broken record, but we are going to look at this equation as if it was a scale that needs to remain balanced. So whatever we do to one side, we have to do to the other side. We don't even have an option at this point. We need to make sure that scale stays perfectly in the middle and balanced. So here, to refresh our memory, whenever we have a letter, a number, and a letter right next door to each other, that means that is a multiplication problem. So to undo multiplication, we need to divide. So I'm going to start by drawing our fraction line underneath each value on both sides of our equation, both sides of our railroad tracks. Now my goal is to get this x all by itself. So I'm going to have to divide by 3. And whatever I do to one side, I have to do to the other. And do we remember all the way back from chapter 4 and probably last year, whenever we have the same value in a fraction, so for example, if I have something like 7 over 7, that is equal to just 1. When you have the same number in your numerator and your denominator, we can go ahead and simplify that to be just 1. So referring back here to our example A, if we have 3x over 3, these two 3's can go ahead and cancel each other out to just give us 1x. However, do we need to write that 1? If we're technically saying 1 times something, isn't that just the same as saying We have our something, or in this case, our x. So we don't write the 1. In our math world, we do not need to write the 1. We just simply leave this as x. And we have x equals 15 divided by 3, which gives me 5. So the answer to letter A is x equals 5. And if we're not sure, a really great strategy is to check our answer or check our solution. So we have 3x equals 15. And then we're going to go ahead and plug in this 5 everywhere we see an x. So we have 3 times 5, and we need to know, is that equal to 15? And 3 times 5 does equal 15. Woohoo! So both sides of our equation or our scale is balanced. 15 does equal 15, so that's one way to make sure that we are correct. And that for letter A, x equals 5. Now we're gonna go ahead and solve letter B. So letter B, I will go ahead and solve in green. Letter B, I'm gonna go ahead and do over here. So my equation is 8 equals 4x. And please, please, please don't forget that I need you to show your work exactly as I am doing it here. I need you to be writing out the equations. I need you to be drawing those railroad tracks. I need to see all of your work being shown if you would like to receive full credit. Okay, so the very first thing I need to do is go ahead and draw those railroad tracks. Now I see that this is a multiplication equation, so to undo multiplication, I'm going to divide. And what is connected, or right next to my variable, is the 4. So that's how I know that I need to divide each side by 4, because I am trying to get my x to be all by itself. And once again, let's make sure we're writing this this division as a fraction. If I see that classic division symbol, we are going to have a big problem. So we have 4x divided by 4, and these two x's are going to go ahead and cancel out to just leave me with x on this side of my equation. I go to the other side of my equation, the other side of the railroad, and I see that I have 8 divided by 4, which leaves me with 2. And we're going to be proper, awesome mathematicians, and we're going to go ahead and write this in the correct order, which means our variable goes first. Our variable x equals 2. Okay. And for our last example, letter C. Letter C, the first thing I'm going to do is go ahead and draw in those railroad tracks. The next thing I see is that 2 is connected to my x, so I need to figure out a way to get rid of that 2. I don't want that pesky 2 hanging out. I'm just trying to figure out what x is equal to. So I'm going to divide each side by 2. And when I do that, these two 2's cancel out, leaving me with my goal of just x on one side. And what is x equal to? Well, x is equal to 14 divided by 2, which is 7. So my final answer for letter C is x equals 7. If you still don't believe me, we can go ahead and plug in this 7 everywhere we see an x. So we have 2x equals 14, and we need to see, ooh, is 2 times 7 equal to 14? I just don't know. Let's find out. Let's see. If we recall our multiplication facts, 2 times 7 equals 14, and that's what we needed it to equal, and the crowd goes wild. Yes, we get it correct. So this is once again a great strategy to make sure that you are going to get every homework question and every test question correct. So now that we're pretty fluent in solving these equations, these one-step multiplication equations, let's practice changing our algebraic phrases to our algebraic expressions. So in 2004, Penn Hadow and Simon Murray walked 680 miles to the South Pole. The trip took 58 days. Suppose they traveled the same distance each day. Write and solve a multiplication equation to find about how many miles they traveled each day. So the first important piece of information that we can go ahead and take out is that it's asking us point blank to write and solve, don't forget that, and solve a multiplication equation to find out how many miles they traveled each day. So each means one, right? We need to find out how long they traveled in one day. So there's a couple things that we need to know. The first thing we need to know is that their trip took a total of 58 days. Okay? And we walked a total of 680 miles. But how many miles did we walk in one day? That's what we're trying to find out. So I know that I walked a total of 680 miles. But I don't know how many miles I walked each day, so that's going to go and be my variable on the other side. I'm going to use M to represent my miles. But I do know that I walked for 58 days. So when I go ahead and multiply my 58 days by the number of miles I walked each day, I get my total amount of miles. So we did a great job on writing this equation, but now we got to solve it. We can't forget about that second step of the problem. So I have 58m equals 680. And I start solving this problem the exact same way that I have solved the rest of them. I need to go ahead and draw in those railroad tracks. And I see that there's a 58 connected to my variable, and I'm trying to get that variable to be all by itself. So I'm going to go ahead and divide each side. Oops. Sorry. Gets a little tricky sometimes to work with. I'm going to go ahead and divide each side by 58. It's a little tricky to draw some of these numbers sometimes. 58. And over here, 58 over 58, go ahead and cancel out, which leaves me with just m on this side of my equation. And for the other side, I have 680 divided by 58, which gives me an answer of 11.7241 and a bunch of other numbers. So let's take a look back at our question. It says, write and solve a multiplication equation to find about how many miles they traveled each day. So I'm going to go ahead and I'm going to round this to the nearest whole mile. Okay, so they walked about, I have 11.7. So that 7 means that I need to make my ones place go up. So M equals about 12 miles a day.